Welcome. In this video, you will learn about another major technique for calculating integrals: integration by parts. This will allow you to deal with integrals of the product of two functions, such as the integrals of 3x plus 4 times cosine of x and x times e to the power 4x. Unlike the product rule for differentiation, this method will not directly tell you the primitive function of a product of two functions. It will only rewrite it to another integral. Hopefully, the new integral is simpler though. Speaking of the product rule, let us recall it. The derivative of f times g equals f prime times g plus f times g prime. Thus, for example, the derivative of 3x plus 4 times sine of x equals 3 times the sine of x plus 3x plus 4 times the cosine of x. We can now use this observation to calculate a primitive function of 3x plus 4 times cosine of x. The first step is to write the relation as 3x plus 4 times cosine of x equals the derivative of 3x plus 4 times sine of x minus 3 times sine of x. Integrating both sides, we get that the integral of 3x plus 4 times cosine of x equals the integral of the derivative of 3x plus 4 times sine of x minus the integral of 3 times sine of x. Now we know that a primitive function of a derivative equals the original function. Moreover, we know a primitive function of the sine. Thus, we obtain that the integral of 3x plus 4 times cosine of x equals 3x plus 4 times sine of x plus 3 times cosine of x plus a constant. We have just calculated the integral of the product 3x plus 4 times cosine of x by reversing the product rule. Can you use a trick like this for arbitrary functions? Yes. To see how, it is convenient to write capital F for a primitive function of small f. That is, capital F prime equals little f. We now write down the product rule as the derivative of capital F times g equals capital F prime times g plus capital F times g prime, which is little f times g plus capital F times g prime. We can rearrange this equation to little f times g equals the derivative of capital F times g minus capital F times g prime. Integrating both sides gives that the integral of little f times g equals the integral of the derivative of capital F times g minus the integral of capital F times g prime. An antiderivative of the derivative of capital F times g equals capital F times g, so we obtain that the integral of little f times g equals capital F times g minus the integral of capital F times g prime. Let us now look at what this formula does. In order to calculate the integral of the product f times g, it suffices to calculate the integral of capital F times g prime. That is, one of the two terms in the product has to be integrated, whereas the other term has to be differentiated. Using this rule to rewrite the integral on the left-hand side is called integration by parts. If we apply this to the first example, you see that we take f equals cosine of x and g equals 3x plus 4. The primitive capital F then equals sine of x and the derivative g prime equals the constant function 3. Thus, we recover the formula we found before. Whenever you want to apply integration by parts, the goal is to ensure that the new integral is simpler than the original integral. If you are calculating an integral and want to use integration by parts, there are several choices you have to make. First, you need to decide how you write the original integrand as a product of two functions. Secondly, you need to choose which of the two functions plays the role of g and will be differentiated, and which is f and needs to be integrated. Let us now consider the example x times e to the power 4x. We want to calculate the integral of x times e to the power 4x, and it seems obvious to split the integrand as x times e to the 4x. Which of these two functions shall we integrate and which shall we differentiate? For e to the 4x, it does not matter if we integrate or differentiate, as the function will be just multiplied by a constant either way. For x, integration gives 1/2 x squared and differentiation the constant 1. As a constant function is much simpler than a quadratic one, we differentiate x. Thus, we set f equal to e to the power 4x, so its primitive capital F becomes 1/4 e to the 4x. And the function x is g, so g prime becomes the constant function 1. Carefully applying the formula for integration by parts, we then obtain that the integral of x times e to the power 4x equals 1/4 e to the power 4x times x minus the integral of 1/4 e to the power 4x times 1. We are left with 1/4 times the integral of e to the power 4x dx. The new integral we need to calculate is simpler than the one we started with. Indeed, we have that the integral of e to the power 4x equals 1/4 e to the power 4x plus a constant. So our final result is that the integral of x times e to the power 4x equals 1/4 x e to the power 4x minus 1/16 e to the power 4x minus 1/4 c. It's rather inconvenient to leave the minus 1/4 c in the final result. As c is some undetermined constant, any multiple of c by a fixed amount is a different arbitrary constant. Thus, for convenience, we give it a new name, say d, to get that the integral of x times e to the power 4x equals 1/4 x e to the power 4x minus 1/16 e to the power 4x plus a constant d. Now, try integrating by parts yourself.